All right, guys, so today we are going to be talking about scatter plots and doing some notes on scatter plots. But before we can begin taking notes on scatter plots, I wanted to make sure that we reviewed and remembered what the different types of functions are and what they look like. Okay, so first we have our linear functions, and I know that you should, and you know what a linear function is, I hope. But I just wanted to do a quick refresher of all of the functions. So if we had y equals x plus 3, our graph would look something like this, where my y-intercept here is a positive 3, and I have a positive function because my x, as my x is increasing, my y is increasing. So this is a positive linear function. Okay, now if I had y equals negative x plus 3, what's that going to do to the graph? Well, because of this negative sign here, I am now going to have still my y-intercept of positive 3, but now my slope of that line is going to be going down because I have a negative slope based on the equation that was just provided to me. So this is a negative linear function. Okay, so just a quick review. Now we're going to talk about quadratic functions, and we have not learned about quadratic functions yet. That is yet to come in section 5 and section 6, but we have talked about them in section 3. So to review what a quadratic function is and what it looks like, I wanted to give you some examples. Okay, so I'm going to move this down a little bit because it's going to bug me. There we go. All right, so our first example, and for my quadratic functions especially, I'm going to use my function notation. So f of x, and remember f of x is equal to y. They're the same thing. It's just a fancy way of writing y. So if I had f of x is equal to x squared, my graph, my image is going to look something like this. Okay, I have that U shape. And because I have a positive number here, it is opening upwards, okay? So that is what f of x equals x squared. And the key here with a quadratic function is anytime we have a squared, a variable that is squared, we are going to have a quadratic function, okay? Now if I had f of x is equal to x squared minus 8, this negative 8 here is going to affect where that parabola is, where that U shape is on my y-axis, okay? This is my y-axis right here, and that negative 8 is going to cause that U shape to drop down to negative 8 here. So it would be something like this, where this point on my y-axis right here is negative 8, because whatever that constant is what's going to move that parabola either up or down on my y-axis, okay? But I still have that x squared. But I could also have a negative quadratic function. So if I had f of x was equal to a negative x squared, okay, I still have that exponent here of squared. What that parabola is going to look like is this. It's going to be upside down. And because of that negative, what happened was I flipped over the x-axis. So negative equals a flip over the x-axis. Okay? So if you have a negative quadratic function, it's going to look like it's upside down. The last type of function that I want to review is an exponential function. Again, we have not learned about exponential functions at this point. That's going to be section 7. We did review them in section 3. but you were just introduced to them briefly. So I wanted to reintroduce you to the exponential function and show you what it looks like on a graph. Okay, so this first one, again, we're going to use our function notation, so f of x. So if f of x is equal to 2 to the x power, this exponent, that variable is an exponent now, and because my variable is an exponent, I have an exponential function. So that graph would look something like this, okay? That is a positive exponential function. Now you can also have an exponential function that is going in the other direction. So if you have f of x is equal to 0.5 to the x power, again, my variable is still in the exponent position, then I would have an exponential function that looks like this. So the increase is on the left side of the y-axis instead of the right. And that's happening because of this number, okay? So if my number is greater than 1, then it increases on the right. Or is called a positive exponential function, okay? If my number is less than 1, then it increases on the left. Or is really a negative exponential function, okay? And that's because what's happening is as your x is increasing, your y is decreasing. So that makes it a negative function, okay? Don't worry too much about the exponential functions until we get to section 7, okay? But I just wanted to show you what they will look like, because you're going to have to identify the lines of best fit for these scatter plots, and they refer to, lo and behold, linear functions, quadratic functions, and exponential functions. So a scatter plot is a graph of data points that shows the relationship between two variables or bivariate data. Two variables, bivariate data, they mean the same thing. So here on this linear scatter plot, you can see that we have a positive linear relationship. Okay, here we have, if we try to make a line of best fit for our quadratic scatter plot, you would see that we have a U shape or a parabola, technically, which is a positive quadratic. Okay. Then finally, we have our exponential scatter plot. And I can see that as my x is increasing, so as my x goes up, my y is also increasing. So I have a positive exponential function. So now that we have seen examples of our linear, quadratic, and exponential functions, now let's take some data. We need to plot the points on our graph and then see which one would be our best fit, a linear, quadratic, or exponential function. Okay, so when we're dealing with a table, we're going to make sure that we are labeling our axis. So we have our y-axis, and I'll make that green. And we have our x-axis, and I can make that orange. Okay, so that's how I'm going to plot the points on my coordinate plane. So where my x is -4, my y is going to be 9.8. So -4, 9.8, about right there. I'm going to zoom in just a little bit more. All right. At -3, we're at 4.1. So -3, 4.1, about right there. -2, we're at 2, right there. -1 on my x, 1.2 on my y, about right there. Then I'm at 0, 0. Put a big dot right there. When I'm at +1 on the x-axis, I'm at 0.9 on my y-axis, so right there. At 2 on my x-axis, I'm at 1.9. Okay, at 3, I'm at 5, so all the way up to 5. And then finally at 4, I'm at 10. Okay, now looking at this data, if I traced the data, what type of function would I have? What would be the best fit for this data? Well, that would be a quadratic function. That gives me the parabola, that U shape, okay? So quadratic. Which function would be the best fit for this data? So they gave us 4 equations, 4 functions, and we have to figure out which one is the best fit. Well, I like to use process of elimination. So A, I know is not the right fit because that is a linear function. So I can cross that out. B is not the correct fit because that's an exponential function. Okay, then I have, C, that was C. B and D. Both B and D are quadratic, but something's standing out to me over here on D. See this -8? That means that that parabola would be crossing the y-axis at -8. So this is not correct because the y-intercept equals -8, and the y-intercept on what I graphed was 0. So here my y-intercept is equal to 0, and that is correct. So that means that B is the correct answer. Okay. Then question 3 says estimate where the function will be when x is equal to 8. Okay, so x is equal to 8 was not given to us in our table. So what we need to do is we need to take this function, y equals 1/2 x squared, but now we're going to fill in that 8 for my x. So really, we have f of 8. Again, remember, f of x is just a fancy way of writing y. So f of 8 is equal to 1/2 times 8 squared. Well, 8 squared is equal to 64, so I'm going to have 1/2 of 64, which is equal to 32. So 32 is the estimate when my x is equal to 8. So what that means, they didn't tell you what this particular graph means. So when x is equal to 8, we can estimate that the y is going to be equal to 32. Okay, so what that would look like, sometimes what you will see is when x is 8, we can estimate that the y is 32, because this is my x and this is my y. Okay, so please don't forget how to list your ordered pairs or your answers when we're dealing with functions in algebra. All right, we're going to go on to our next question. Our next example, our practice problem, says the table shows the amount of snow in inches on the ground as the temperature rises. Graph the data below, then answer the questions. So again, I have my temperature, okay? My temperature is my x-axis. I highlighted that wrong, thought so. It's all right, I can fix it. So my x-axis, again, is orange. My y-axis, the snow in inches, will be my y. Okay. So now I'm going to take the data that they gave to me in the table and plot my point. So when the temperature is 0 degrees, I'm at 9.9. So I'm going to put a point there. Okay. When the temperature is 11 degrees, I'm at 8.4. So I'm going to go to 11 degrees on the x-axis and go to 8.4. When the temperature is 19 degrees at 6.8 inches, so at 19 I'm at 6.8. At 31 degrees I'm at 5.1, so just a little over 5. At 40 degrees I'm at 3.6, so at 40 degrees I'm at 3.6. And then finally, at 49 degrees, I'm at 2. So right about here. Now looking at this data, if I drew a line through this data, I would see that it is a linear function. And specifically, this is a negative linear function. Would be my line of best fit for this data. So which function would be the best fit for this data? Well, I've got A, that is linear. B is a quadratic, so we're going to cross that out because it's a quadratic function. C is an exponential function, so I'm going to cross that out. Okay, so now we are left with A and D. Both are linear functions, but there's a key difference between them besides just the slope. But let's look at those y-intercepts. So A is saying that my y-intercept is positive 2. D is showing that my y-intercept is a positive 10. Well, that definitely matches the data much better. So this is the correct function for the data that they've provided. And now I need to estimate how much snow will be on the ground when the temperature reaches 55 degrees. Okay, so what I'm going to do is I'm going to take that 55 degrees and plug it into my function. So f of 55 is equal to negative 4 over 25 multiplied by 55 plus 10. When you do that in a calculator, you're going to find that at 55 degrees, there's about 1.2 inches of snow left on the ground. I've already done the calculation, but you can go ahead and check that calculation in a calculator. You would do negative 4 over 25, so negative 4 divided by 25, multiply by 55, get that answer, and then you would add 10. Once you add 10, you'll see that your answer is 1.2 inches. Okay? We're going to do one more practice problem, and then the last 2 practice problems will be done on your own. So again, we have the table shows how the population of a town grew every 6 months after 2010. Okay, the key point is after 2010. Graph the data below, then answer the questions. So here's my y-axis, and my y data is going to be the population in thousands. And then I have my x-axis, and that is going to be the years after 2010. Okay, so let's go ahead and plot these points. And I'm going to go ahead and zoom in so I can get as accurate of points as possible. So at 0 years, my population was 2,000. So I'm going to put a point right there. At half the year through, I was at 2.4. So just a little bit higher. At 1 year, I was at 2.9. So almost to 3. Okay. At 1.5 years, I'm at 3.8. So not quite to 4. At 2 years, I was at 4.8. So almost to 5. At 2.5 years, I was at 7. Right here. At 3 years, I'm at 9.2. So not just a little over 9. At 3.5 years, I'm at 12.5, making a little bit more of a jump. And at 4 years, I'm at 17.4. Okay, now looking at this data, what type of function do you think I have? Well, this looks like an exponential function would be the best fit for this data. So which function would be the best fit? Well, let's look at our options below. Option A is a quadratic, so we're going to cross that out. Option B is a linear, so we're going to cross that out. C is exponential, so maybe. And D is also a quadratic, so we're going to cross that out. So our correct answer here is C, which is y equals 2 to the x power plus 1. And then it asks us what the population of the town was in 2015. Okay, it's key to note that it's not asking us to plug in 2015 for x, but we need to figure out how many years it's been. So that means our x is going to equal 2015 minus 2010, which is equal to 5. So I'm going to plug in that value of 5 in for my exponent in the function. So I'm going to find f of 5 is equal to 2 to the 5th power, because that's where my variable is, plus 1. 2 to the 5th power is 32. Oops. Plus 1, which is equal to 33. Now they told me that this is population in thousands, so I know that my answer is going to be, scroll up a little bit, 33,000 is what the estimated population will be in 2015. Okay. There are 2 more practice problems that I want you to do on your own on the page. So try those on your own, then submit a picture of your notes for today's classwork assignment. Message me if you have any questions. Have a good day.